Only I think 3 questions. We won't take very long. Why? What's wrong? Why? So show that YZT is 90 degrees. YZT, this particular angle over here. To show that it's 90 degrees, we need to use the converse of Pythagoras theorem. So our working will be as such. So this one very important because most likely they will test you also. Let us compare the square of the hypotenuse, the longer side, which is YT. YT square has a value of 8.5 square. So calculator 8.5 square gives us 72.25. So our objective, Enhui, can see or not? It's too thin. Okay, let me choose a dark, thicker pen. YT square, is this better? Okay, so we were saying 8.5 square, giving us 72.25. We want to compare this value with the sum of the squares of the 2 shorter sides, meaning our 4 and 7.5. So let's write it down. YZ square plus ZT square. You are showing the marker. You know what you're doing. You are trying to add up the sum of the squares of the 2 shorter sides. So 4 square plus 7.5 square. And then you get 72.25 again. You should be happy to see this because now it is the same as our square of the longer side, which is equal to YT square. So by writing it this way, you have already shown that this part equals to this part. So continue with our statement. Since YZ square plus ZT square equals to YT square, okay, we have shown the working already. Then by the converse of Pythagoras theorem, that angle, which angle? YZT equals to 90 degrees. They say show, right? So you write down shown. Take note of the presentation. You cannot start off by writing, YZ square plus ZT square equal to YT square. You cannot write it that way. Because if you start the first line with Pythagoras theorem, you are already saying that it is a right angle triangle. But you do not know that yet. So that will be the error. And this is the other word that you need to know, converse. Knowing this, actually this word is not new. We learned it in angles already. Converse of corresponding angles, parallel lines, alternate angles, parallel lines, interior angles, parallel lines. Next one. Find the length of XT from X to T. So this is our next question. Well, with the 2 shorter sides, X to Z, total distance 10 cm. Z to T, 7.5 cm. You can find out XT by yourself. Okay? So the working will look like this. Part B, part 1. X T square root of 10 square plus 7.5 square. So 12.5 cm. And find the shortest distance from Z to TX. Highlight this question. Where exactly is the shortest distance in the diagram? It is actually the perpendicular distance. Shortest distance will be a perpendicular distance from Z down to X to where? TX. I didn't write clearly, but is this TX? Do you remember? I think it is lah. I don't have the question with me. Anybody got a textbook? Okay. I'm surprised. And we do so, we try and find out this value by using area of the triangle. So this was something that we did last time already in Sec 1. Part 2, area of YZT, half times the base. We choose the base as 4 times 7.5. So this gives us 15. 15 square centimeters. But now we're going to equate this same area with the same triangle, but the base as 8.5. So our 15 square centimeters will also be equal to half times 8.5 times the shortest distance h. So in your presentation, somewhere you just put down that this is our h, which is what you want to find. So half times your 8.5 as your base times your new h also must give you 15 square centimeters. Because it is the same triangle, it must have the same area. So times 2, 30, 30 divided by 8.5, we get h equals to 3 and 9 over 17 cm. Very weird number. But that's how it's done. Now question 14. In 14, find the values of QP square. Okay, this is quite unique. Usually they will ask you to find QP, PB, and VQ. But this time they want the square. Okay, so let's start with the first one. QP square. Over here. QP square by our Pythagoras theorem. 18 square plus 7.5 square. $380.25. Next one, PB square. 5 square plus 12 square. This one I memorized already is 169. Because 5, 12, and 13 is a Pythagorean triplet. The last one, BQ square. BQ square, I'll need this distance and I'll need this distance. This, because it is a rectangle, this will be 18. Because this is a rectangle over here, that will be a total of 12 minus 7.5. 12 minus 7.5, 4.5. 4.5. So we get 4.5 square plus 18 square. Total 344.25. The question is to show in part B that there is an error. Is that an error? Which one? BQ, why? 4.5 square plus 18 square. All right, what? 344.25. What's the error? Oh, sorry. This is not 18. AB is actually 23. Thank you. I never see properly. So 4.5 square plus 23 square. Okay. 549.25. Now is it okay? Okay, thank you. Now part B, show that this is a right angle triangle. Which of these angles do you think is going to be the right angle? Looking at the diagram, which one is going to be the right angle? Angle P, isn't it? Therefore, we should write it as, we should try and find the sum of the squares of QP square and PB square. Add them up, the squares, and you see whether it is the same as QB square. That is our approach. So let's write that down. PQ square of since part A we use QP, so let's use QP square. We want to add that up to our PB square. It has a value of 380.25 plus 169. 380.25. We get 549.25. You added up the sum of the two squares. It turns out that it is equal to BQ square. Turns out they are the same. Therefore, since QP square plus PB square equals to BQ square, by the same thing again lah, by the converse of Pythagoras theorem, triangle BPQ is a right angle triangle. Since they ask you to show, then you write shown. Can? And then the shortest distance from P to BQ, I will just help you identify where it is. From P to BQ. So we noted that this is our right angle already. We want to find this distance. Let's call it H. So same thing, half times the base times the height. We've got a base already. We've got a perpendicular height. Get the area, equate it to half times a new base. This time the base will be BQ. Then times the unknown height. Then you can do it by yourself. Now I'm interested in question 15. In question 15, we've got another right angle triangle with the distance, with all the lengths are in algebra. Wow. Then you know Pythagoras theorem, you need to square all the sides, right? And then in this case, the expressions given to you, they are all made up of two terms. So you're going to be doing expansion of your algebra already. Form an equation. How to form equation? Well, we know that it's a right angle triangle. So the sum of the squares of the two sides must be the square of the longer side. This is us forming the equation. For x plus 1, when you square it, u plus 2x plus 1. You square it. So this is known as the sum of the squares of the two shorter sides. It has to give us 3x minus 4 squared. Pythagoras theorem. We just imagine this as like an A, this is a B, this is a C. You would have written A squared plus B squared equal to C squared. So in the same way, replace all of them back with the original, and this is what we get. And now we are testing you on your algebra, expand everything. X squared plus 2x plus 1, 4x squared plus 4x plus 1, 9x squared minus 24x plus 16. Don't need to do the rainbow if you have already memorized the expansion for your A plus B squared. Now what we have to do is, after you form already, show that it reduces to this. Group all your like terms together. Okay, so since this equation starts with a 2x squared, I would like to put all my x squared to one side such that I get positive x squared. So the options on in this case, x squared, 4x squared, 9x squared. I would want to subtract the x squared, subtract the 4x squared, so that I end up with a positive x squared on the right hand side. So that is my strategy. In common terms, I want to move everything from the left side to the right side so that I get positive x squared. Of course, you can keep it the other way around. Put everything on the left hand side. You will still get the same answer. So let's start with the x squared terms. Subtract 5x squared on both sides. I will end up with 9x squared minus 5x squared. Now I consider all the x terms. On the left hand side, I've got 6x. The right hand side, I've got negative 24x. I'm going to take away the 6 on the left hand side. So negative 24x minus 6x. Take away the 6x on both sides already. Now look at the left-hand side. I've got 1 plus 1, that is 2. I want to get rid of the 2 on the left-hand side. The right-hand side has 16. I take away 2. Now my left-hand side, nothing left. And now I can simplify. The 0 equals 2 can actually be placed on the other side. So I'm going to be lazy. I'm going to say that this is going to be 0, which you can do also. Okay, so now simplify. 9x squared minus 5x squared, we get 4x squared minus 30x plus 14 equals to 0. Wow, happy. I get an ax squared plus bx plus c equals to 0. Then I check. Hey, differently. The question says reduce to 2x squared minus 15x plus 7 equals to 0. Mine is different. 4x squared minus 30x plus 14 equals to 0. So what should you do? You recognize that they are the same, they are similar already? One more step, right? Divide by 2. 2x squared minus 15x plus 7 equals to 0. Shown. So now solve this equation. Can you imagine how we are going to test your Pythagoras and your chapter 5 at the same time already? Like this. We're going to test you this way. To solve this equation, your box, 2x squared. You have no choice. It's going to be 2x and x over here. We want a 7. Okay, so it's either going to be 7 and 1 or 1 and 7. Let's just randomly try. So we got 7x, 2x. This will not give us 15x. Switch them around. 7 and 1. So 14x and x. This has a possibility of giving us the required 15x. But the sign is different. So we include a negative sign. Negative sign. I know it's negative 15x. But don't forget to include a negative sign over here. So that negative 7 times negative 1 still gives you positive 7. So here we have just factorized it. 2x minus 1, x minus 7 equals to 0. This is my rough working. I'll put it to one side. 2x minus 1, x minus 7 equals 0. Solve the equation. Therefore, x equals to half or x equals to 7. We have to decide, are both solutions acceptable? Are both of them okay? So look at it. Both okay? Both okay? Really? How do you decide? You have to substitute back into the question and see whether it makes sense or not. Let's try the half. I know that if I put half in here, I will get a positive number. That's not a problem. I put half over here, I still get a positive number. Not a problem. What if I put a half over here? 3 times half is 3 over 2. 3 over 2 minus 4 is going to be a negative number. Therefore, it will not work. I cannot have a negative length. That's why we decide to reject. And this is our only answer. X equals to 7. Of course, do the same thing. Mentally, you can do it. Put here, put here, put here. You will all get positive. So yeah, it makes sense. By the way, if you are unable to show this equation in part A, you can still continue with the rest of the question. That's the reason why they ask you to show, so that you don't lose everything just because of expansion error. So next one, find the perimeter, find the area. Then you can do it by yourself already, just substitute only. Okay? Now any questions for chapter 8.1? Otherwise, tomorrow we are going through our chapter textbook exercise 8.2 questions found at the end of the notes. Okay, this one. 8.1. Today is Thursday, right? Is it Thursday today? Oh, sorry. Then Friday work. This one, due on Friday. 7, 12, and 14 exercise 8.2. Okay, due Friday, I mentioned before already. How much time do we have left? Okay, 4 more minutes. I want you to stop this.